Yeah. All right. So we're doing exercise number 470 from Brown, 10th edition. It's an exercise in molarity. The question asks if you mix 2.38 grams of sodium chloride with 50 mLs of a 0.4 molar solution of calcium chloride, find the concentrations of sodium, calcium, and chloride. With regard to sodium and calcium, it's just a simple dilution problem because the only source of sodium is the sodium chloride and the only source of calcium is the calcium chloride. But there's a bit of complication when it comes to calculating the chloride concentration because there's some chloride being given from sodium chloride and there's some chloride also coming from the calcium chloride. So the way I approached it was to find the number of moles of each one of the different ions. So the total amount of, first of all, I calculated how many moles of sodium chloride there was. 2.38 divided the molar mass of sodium chloride tells you that there's 4.07 times 10 to the minus 2 moles of sodium chloride, which will also give you 4.07 times 10 to the minus 2 moles of sodium and chloride anions. Now the total concentration, the first one I worked out was the chloride concentration. So I knew I had this many moles of chloride anions from the sodium chloride, and I had 4.0 times 10 to the minus 2 moles of chloride from the calcium chloride. How did I find that out? Well, I said 0.05 times 0.4, see what I did here, and then I multiplied it by 2 because the chloride anions are in a proportion of 2 to 1 to the calcium chloride. So for every mole of calcium chloride, I have 2 moles of chloride anions. So that's how I got 4.0 times 10 to the minus 2 moles of chloride. So the total amount of chloride is 4.07 plus the 4. That gives a total amount of chloride, and all of that was dissolved in 0.05 liters of solution. So the concentration of chloride turns out to be 1.61 molar. For sodium, it's very straightforward. You have 4.07 moles of sodium ions dissolved in 0.05 liters of water. It gives you 0.814 mole per liter concentration. And for the calcium ion concentration, it's 0.4 molar because it's the same as the concentration of the solution. If there's 1 mole of this, then there's 1 mole of calcium. If there's 0.4 moles of calcium chloride, then there's 0.4 moles of calcium. So the concentration of calcium ions is going to remain the same. The second question is a dilution. We start off with a 14.8 molar ammonia solution, and we want to make 100 mLs of 0.25 molar ammonia. So we use the dilution equation. M1 V1 equals up to V2, where M1 stands for the molarity at the outset, V1 is the initial volume, and M2 and V2 stand for the final concentration and volume. The only thing we're missing is V1. We're asking us how much of this stock solution do we need to make 100 mLs of this concentration. So we fill in all the values, substitute in all the values, we isolate V1, and it comes out to 1.69. Notice how I used mLs. It doesn't matter what you use as a volume unit, as long as you use the same unit in both V1 and V2. I could have said 0.1 liter, and I would have gotten a result of 0.000169 ml. The important thing is that you use the same unit consistently. So I used mLs, so the answer here is going to be in mLs. And I made a concluding sentence, 1.69 mLs of 14.8 molar ammonia needs to be diluted to 100 mLs to achieve a concentration of 0.25 molar. In the second question, they ask how much of this stock solution is necessary, if 10 mLs of this stock solution is diluted to 250 mLs, what is the new concentration? In this case, what we do is we isolate for M2, 14.8 times 10 divided to 50 gives you 5.92 times 10 to the minus 4 molar.